Alright, I'm going to talk about our endothermic lab. So recall, exothermic means energy is exiting the system. Endothermic means energy is entering the system. Energy is required to make that reaction happen. Enthalpy is our total change in energy, so if you're losing energy, the system's losing energy, that's negative, versus if you're gaining energy, that would be a positive change in energy. Bond energy is energy required to break bonds, and if you want to break a bond, you need energy to do that, so it's endothermic, versus when you make bonds, you generally go to a lower energy state, and that's exothermic. We talked about these two graphs. We have the exothermic over here. Here we have reactants. Energy is absorbed until we reach our peak, our activation energy for the reaction to start, like when you light the fuse of a firework. And then all of this energy is released when the firework explodes. We have these low energy products. So low energy products minus high energy reactants gives us a negative enthalpy. Energy is released. On the other side, our endothermic reaction, these reactants gain energy to our activation point, like when a cake bakes at 350, and then we have these higher energy products than reactants. So if we do the products minus the reactants, we'll get a positive number indicating positive enthalpy energy being absorbed by the system. So we're going to look at alcohol. We know that alcohol is a very low vapor point. That means that it evaporates at low temperatures. Even so, we still need heat to evaporate things. So if we leave the cap off of a bottle of isopropyl alcohol and come back in a day or so, we'll notice that there's a significant amount gone. That's because it all evaporated from the heat from the environment. And so if the alcohol absorbed the heat from the environment, which would be an endothermic process. However, if we had a closed system, we could condense it back down. So we're not breaking bonds, we're just moving the molecules further apart, like in a physical change of evaporation. If we look, here's our liquid molecules, here's our gas molecules. Our liquid molecules are gaining enough energy to become a gas particle, and the gas particles are taking that energy with them. So we have our liquid and they spread out to be more gas-like. For this part, we're going to take our cotton swab, soak it in some alcohol, rub the alcohol on your skin, and you'll notice that the part of your skin that has the alcohol is going to feel cold, whereas the part of your skin that does not feels warm. And here's a video that kind of helps better explain that. So they have a thermal camera. We're going to compare water and alcohol evaporation. They're going to stick the straw or piece of paper, whatever it is, in each liquid, take it out. So they take the straws out, and we see the one with the ethanol is blue, indicating that it's very cold. That means that all these ethanol particles are taking the heat energy with them to become a gas. Versus the water one, which is not as blue, there's not as much evaporation happening, so it's maintaining that energy. The energy is not being lost due to evaporation. Here's another video that talks about how sweat works. I'll let you watch this one on your own time. It's a little bit long. The purpose of this lab is to look at endothermic reactions. We know that endothermic means that energy is being absorbed, and those bonds are generally broken. And since the system is taking energy from the surrounding, the temperature of the surrounding goes down because it's losing energy. We used isopropyl alcohol and we used a Q-tip to apply it to our skin. So on your skin, you should feel the temperature of your skin feeling cold because that alcohol is pulling the energy out of your skin to evaporate. If we want to look at the coordinate diagram of this, here's our alcohol. Here it's absorbing all of the energy from the skin and we produce a gas. And so since the alcohol is absorbing all this energy, our surrounding, the skin, is getting cooler because it doesn't have that energy anymore. So our reactant evaporated. This is a physical change that does require energy. The energy to evaporate it came from our body temperature, making our skin the surrounding. And so when the alcohol is evaporating, it's taking the energy from our skin and going to the gas phase. So if we look at our diagram, our reactants are gaining energy, whereas our surrounding is losing it, and our surrounding feels cold. And that's it.